Assalamu alaikum. Myself Sinusoids and my roll number is 21TE09. Here is I am going to explain the DSP Lab 3, which is representations of unit impulse, unit step and exponentials making signals out deltas. Here is the task 1. The lab objective of this lab 3 is the representation of unit impulse functions and unit step functions, making unit step functions using unit impulse sequence, making any arbitrary signals out of deltas. Task 1. Representation of unit impulse functions in MATLAB. Open editors and write following code snippets and save the files with functions names. In this case, impulse sequence is. Here is the input of this task 1. In task 1, first we tell the functions where to place the impulse in the sequence, and here is the n1. n1 defines the starting index of the sequence, and also n2 defines the ending index of the sequence. It's create a sequence of days n starting from n1 to n2, and also it's create another sequence x where each element is determined by whether the corresponding index is equal to n0. If it is equal to the n0, the element in x is set to 1, otherwise is set to 0. Here you can see the output of this task. In task 1, we observe shift the unit impulse to right and shift the unit impulse to left, multiplying the sequence with scalar value and see the effect. In task 2, representation of unit step functions in MATLAB. Open editors and write following code snippets and save the files and the function's name, in this case step sequence M. It is also same the above task 1, and the basic changing of this. First we define the functions and same as the step sequence. n0 tells the function where to place the impulse, and n1 specifies the starting index of the sequence, and n2 defines the ending index of the sequence. And then we generate the step sequence n0 and 1, and here is the you can see the output of this task 2, in which we observe the shift the unit step sequence to right and we shift the unit step sequence to left and multiply the sequence with scalar value and see the effect. In task 3, unit step sequence can be constructed by add shift impulse sequence, in which we use the unit impulse sequence of task 1 and constructions unit step sequence. Is it possible to construct the shifted version of the unit step sequence by some summations of deltas? Yes. If then, what is required to do so? Use command pause and hold on and hold off. Here you can see the input of this task 3, and then you can see the output of this task 3. In task 4, you can see the input of this task, in which we define the arbitrary signals that can be represented by unit impulse sequence. And first we define unit impulse sequence, that is the same as the task 1, and then we define the different functions of xn, that's from 4 1 2 3, and the second one xn, and other is xn, and then we use the command pause, hold on and hold off. Here you can see the input of this task 4 and we generates for 3 signals in the output of task 4. In task 5, in which we separating a signal into evens and odd parts. First we define our functions xe and xom and even odd functions that can be real signals decomposition into even and odd parts, and we define the function and we put the if and if else in this, and we generate the different functions of x and xe, and now you can see the output of this task 5, in which we splitting the signals into evens and odd parts, and you can see the output of even parts, odd parts, and that is given below. In task 6, here you can see the input of this task 6, in which first we impulse trains that can be used for sampling of continuous time signals use following continuous time sequence, that we take the time from 0 to 2 and frequencies 1, and we define the continuous signals, that is cos f 2 pi t, and we use the command of subplots and plot, that is continuous time signals, and we give the titles of this task continuous time signals, and we use the x label and y labels. And here you can see the input, and also you can see the output of this task 6.